We're going to talk about printing overview. So the basic print settings are: nozzle is, like I said earlier, it's going to be very similar to regular PLA. Nozzle temperature of 210 C, a flow rate of 135%, or extrusion multiplier 1.35, depending on how your slicer names that setting. The sweet spot for infill is 70% infill with 3 wall lines. Now, if you want to go outside of that, well, I want my part to be 100% thick, or I want my part to be 100% hollow. We have tips for going outside of that 70% infill as well in a podcast about how much infill should I use. So Austin will throw a link to that in the chat as well. Now, what support material should you be using when printing with Filamet? You will use any support material that you would use with standard PLA, including PLA itself. So all of that support material will be broken off. Using the PVA water soluble support is a great option as well, because then you can just soak all of that off before you go into the heat process. Now I'm going to hand it over to Brad again to talk about making adjustments as you begin the printing process. He'll talk about those 2 photos that you see here. And Brad, talk to us about clogs as well in your discussion.
Sure. So in the photos, this is a bronze piece, the photo that's on the left. The one on the left of that is under extruded. So there just wasn't enough material coming through the print nozzle to fill in all of the area that was meant to be covered by the 3D print. The one on the right is about perfect. This is about where you want it. These lines are, the print lines are quite visible in this one, and depending on your printer, that will vary, but that's what it should look like. The one to the right of that is an over extrusion. So this is one where the infill was 100%, or at least the top few layers were at 100%. And more material was being put on the print than there was space available. So the nozzle winds up pushing the material to the edges of it and will build up like little attachments to the outside of the 3D print. Let's talk about, okay, so the infill, 70% infill, the reason this works well is that it isn't solid. And at 70%, 30% of it is open space. So that provides channels for the gases to escape during the debinding process. And there are always exceptions. It can be printed at 100%. There's ways to do it. It can be printed at nearly hollow. There's ways to do that also. It just takes a little bit of understanding.
So let's talk about clogs as well. Sometimes, yes, your nozzle does just get clogged up with filament, but a lot of times what looks like a clog isn't really a clog. Excuse me. And one example of that is that the material needs just a bit more room between the nozzle and the print bed on the first layer to squeeze out this thicker material than PLA. So Brad, talk to us about some common things that can look like clogs and ways to correct those.
Yeah, the number one most common is what you were described, where you need a slightly greater Z offset to keep the nozzle away from the build plate so that there's room for the material to extrude. Our composite materials are very viscous compared to regular PLA. They have a consistency more like bread dough than a liquid plastic. What was next?
We were just talking about clogs. Is there another way, or when you do have an actual clog, how do you clear that out?
Okay, right. And the second most common thing that looks like a clog, but it's not. Well, technically, it isn't when it started, but it becomes one. So our materials have lots of metal in it, so they conduct heat really, really well. So you'll have a situation called heat creep, where heat that was at the nozzle will climb back up through the filament to the point where it gets to the drive gears and it becomes soft. And this will initially present as a clog, but it's not. The material could still flow. It isn't, the nozzle isn't mechanically clogged. But then what happens is it sits there and then it does become clogged. The general remedy for fixing a clog is just like PLA. You can take the nozzle off and run it out with a drill bit, or most people that do a lot of 3D printing have their own favorite technique for correcting a clog. And what you use with PLA is what you will use with Filamet.
Now, one of you had asked about filament storage in your registration form, and also thank you for filling out what you wanted to learn in the podcast today. That really helps us tailor it to you. I'm sorry, the webinar today. Filament storage, you don't need to worry about any special conditions for storing your filament as long as it's in a standard climate control indoor environment. You want to keep it away from direct sunlight. You want to keep it away from direct heat sources, storing it right in front of a register, for example. But in standard indoor climate controlled environment, your filament can be stored open. If you are in a very humid environment, you may need to work on finding a drier place for it. Do not dry your entire filament spool at once. Do not put your spool in a filament dryer. It will render the entire thing brittle and unusable. It's important to only use that filler warmer for heating your spool. Don't heat your whole spool at once.
Quick question, guys. Yeah, I got to run, so sorry about this, but I was really curious before I go. What's the loading ratio with that copper? Is it like 70% resin and, or sorry, 30% resin and 70% copper? What's the loading ratio on that?
Yeah, all of our materials have a different material loading. Copper is something around 90% copper, 10% plastic, but all of those percentages you can find on the products page of our website.
Great. And then the other one, have you tried for those thick pieces? Have you tried to soak them in acetone for a couple days and then debind it after, or get the binder out that way?
Right. So you're describing a solvent debind, and we have not found a good way to do this.
Okay, gotcha. Well, I do that with Tethion's Genesis resin, but it probably is different with your guys' process. But thank you for enlightening on that. I appreciate it.
It's pretty resistant to solvents. The best solvent we've come up with so far is dichloromethane. That will at least break down the polymers a bit, and tetrahydrofuran also can work. But we haven't done a lot of development in that direction.
Thanks, I appreciate the.
So gang, these basic print settings are all on the website. You don't have to rely on what you're learning in the webinar today for all of the information. The Learn tab on the website is where you'll go. I'll mention this several times, but all of the print settings are listed there. If you have a Bamboo Lab or Ultimaker printer, we have a couple of additional resources for you on our YouTube channel. Just search for Bamboo or Ultimaker, and you'll find some additional printing tips and tricks for those two printers. The Bamboo Lab actually makes it a little easier, fewer things to adjust. And then we have some tips for setting up your filler warmer with the Ultimaker on the YouTube channel as well.